Hello everyone, welcome to this video. In this video we shall going to see another explanation for Dn in which we need to explain geometrically that a rotation followed by a rotation must be a rotation. In the previous video we saw that reflection followed by reflection is a rotation. Here we need to prove that rotation followed by a rotation is a rotation. So again we are looking at the case of D3. So when n is 3, we are considering the group D3 dihedral group of symmetries of equilateral triangle. So from this fact we will verify this result, and this result would be true in general for Dn also. I am not providing you with the proof because the proof would be more theoretical. I wanted you to look at the results geometrically through the eyes. So I am taking the case in which we are discussing the group D3 in which all the cases would be discussed in minimum number of steps, right? So first of all, let's see the Cayley table here. We wanted to look at rotations. These are the rotations and these are the rotations. For these rotations, you see the resultants, they are also the rotations. So this is what we are saying: a rotation followed by a rotation must be a rotation, right? So therefore a rotation which is followed by rotation, it either fixes every point. So that means if every point is fixed, so that means that rotation is an identity rotation R0. This is obtained in these three cases. When we have R0 with R0, right, the result is R0. Or when we have R120 with R240, the result is R0. Or when we have R240 with R120, the result is R0. So here in this case you can also look geometrically that when we take equilateral triangle ABC, we are rotating it by 0 degrees, so that means we are not doing anything to it. That is the same. And again we are rotating it by 0 degrees, so we are not doing anything to it. So that means the initial triangle has not been disturbed at all, and hence the final result is R0 of the initial triangle. So this operation here is R0, correct, in the first case. Similarly, so that means rotation followed by rotation is a rotation. Similarly for R120, when you rotate this triangle by R120, so you are shifting A to B, B to C and C to A, right? So this is the triangle. Now for this next triangle, when you apply R240, so that means you are shifting this C to B, A to C and B to A. So that means you are getting back ABC. So you see this ABC here and this ABC here are the same. Hence in moving from here to here, we are applying R0. That means we are not doing anything to it, right? For the next transformation, we have rotation by 240 degrees. So that means A is going to C, B is going to A and C is going to B, correct? This is what is happening. So we have this triangle. Now on this triangle, what we are doing, we are applying R120. So B is going to C, C is going to A is going to B. So we have this triangle. Now look at the results here. This triangle and this triangle are the same. So that means in moving from here to here, we are applying R0. So that means the identity transformation, and nothing is being done over here. So in this case, we have a identity rotation. So rotation by a rotation which fixes every point is the identity rotation. So this proves the result in this case. For the next case, let's take different rotations, right? Another cases. So in order to discuss the remaining cases, so that means this result, this result, this and this result, let's have a look. So suppose we are taking R0 with R120, the result would be R120. R0 with R240, the result would be R240. R120 with R0, it would be R120. R120 with R120 would be R240. R240 with R0 is R240. R240 with R240 is R120, correct? So these are the results here. So let's have a geometrical look at all these results. So in the first case, when we are taking first of all rotation by R0, 0 degree, so the triangle would be the same, right? Next, when we apply R120 to it, so A would go to B, B would go to C, C would go to A. So we have this triangle. So overall we are having the result as R120. So rotation followed by rotation is again a rotation. Next, For the second case, we have R0, so that means nothing is being done over here. What about 240? This A would go to C, B would go to A, C would go to B, right? So we have this triangle over here. So that means we have overall a shift of our rotation by 240 degree, right? So therefore, this is again rotation by rotation gives us rotation. Next, in the next case, we have to see that first of all we are applying R120, so A would go to B, B would go to C, C would go to A, and hence we would have this thing. Next we are applying onto this triangle R0, so we are doing nothing. So that means for moving from here to here, what we are doing, we are applying R120 to it, so again a rotation. Similarly, we can see for the remaining cases, we are having from here to here, we are having R240. From here to here, we are having again R240, and from here to here, we are getting R120 as the result. So in each of the case, rotation followed by rotation gives us rotation, and hence in D3, in all the cases, we see that a rotation followed by a rotation must be a rotation, and this is very well clarified by looking at the scalar table. So I hope you understood this result well. Well, that is it for this video. Thank you for watching.